Hey folks, so we're going to take a look at this example here. It's basically just going to be a fairly straightforward 2D equilibrium problem. This is just to give you a little bit of a chance to have some more practice. Now typically what I would start with is drawing the free body diagram and drawing that as neatly as possible using a ruler, identifying all the support forces, all the reaction forces, and all of that. But since drawing on this tablet is quite difficult, I'm not really able to use a ruler. It messes with the touch screen. I'm just going to use the existing diagram of the problem, and I'm going to go ahead and draw forces over the top of it. Okay, so we're looking at this member BCD, and we're going to have a force obviously at B right here, which is going to be orientated along that cable like so. And then at C, we're going to have two components. We're going to have, we'll call this CX, and we're going to have CY. Okay, and we're going to keep our coordinates in the usual kind of orientation. Let me redraw that just a little higher up. We'll have our X and our Y. Okay, so we've got that. We're just going to use that. All the dimensions are already written on there. And we are going to go ahead and start working on, first of all, part A. We need to find the tension in the cable, and then we want to find the reaction at C. Yeah, so we're trying to find all these unknown reactions. So when you first look at this, take a think. If we sum forces in Y, we're going to have a Y component of this tension AB. Let's just label that force. As TAB. We're going to have a Y component, obviously, of the reaction force at C as well. So that's two unknowns. If we do it sum forces in X, we'll have an X component of TAB and CX. So again, two unknowns. So maybe if we try and simplify things a little bit by taking a certain moment, we're going to, if we take a moment about C, we will then, our only unknown is going to be TAB, yeah, because we know the direction of that force. So that's going to be our starting point. Now, we won't necessarily always take the sum of moments about a hinge point or something like that, but quite often it's a good place to start because we eliminate those reaction forces because the moment of CX and CY about C obviously is 0. So first of all, we have to figure out what the direction is of this TAB. We want to find some of these angles. So let's say we want to find this angle here. Let's call that angle theta. So to find theta, so that we know that we can resolve that direction of TAB, we're going to say theta is equal to the inverse tangent of the opposite over the adjacent. So our opposite is 0.24. Our adjacent is this height here from B to C, which is this 0.18 meters. 0.18, okay, and then we'll just go ahead and figure that out. So we have an angle there of 53.13 degrees is our theta. Next thing we do, we're going to take that those moments about C, okay? So let's go ahead and take the sum of moments about C. We know that that's going to be equal to 0. We're taking counterclockwise as our positive direction. So let's go ahead and do that. So what do we have? We have, in the counterclockwise direction, we have this component of TAB is going to be in the negative X. Sorry, this is kind of a mess. I'll erase this in just a sec. But that component is going to be in the negative X, yeah? And now it's on the opposite side from the angle theta. So we're going to use sine. Let me just clean up some of the mess I've made here. So that's going to be in the positive direction, so TAB sine theta, and the multiplied by the perpendicular distance here, which is that 0.18 meters. The Y component of TAB is going to pass directly through C, so that won't count. CX and CY won't have any moment about C, so we just have these other two forces out here that I will add to the equation. So I've just gone ahead and written out the rest of this equation with these 240 Newton forces. Both of those are going to give a clockwise moment about C. So you'll notice I've used these negative signs out front there. So now the only unknown I've got in here is TAB. So I'll go ahead and solve for TAB. If you're following along, this would be a good time to go ahead and pause the video and work that out yourself with the numbers that we have written in here. So if we go ahead and work this out, hopefully you've done this and found the same answer as me. TAB is going to be equal to 2000 newtons. okay, is the value of that tension force if we solve this equation. So next thing now, we can come ahead and we can do sum of forces in X, sum of forces in Y to find what's going on with C. So let me just go ahead and start writing those equations out. So we'll do sum of forces in X is equal to 0, right, to maintain the equilibrium of our body. So we're going to have minus the X component of TAB, so minus TAB, because that's in the negative X direction, yeah? Minus TAB sine theta, plus CX we've written in the positive X direction, and that's all we have, right, because these other two forces are all in the Y, in the vertical. So that's equal to 0, and then therefore we can quite easily solve for CX. So again, go ahead and pause the video at this point and see if you can work this out. If you've gone away and done that, hopefully you found that CX is equal to 1600 newtons. And we've got a positive value for that, so that must mean it is in the positive X direction, like so, which is the way that we drew it. Next thing, we're going to look at sum of forces in Y. So we're going to have TAB. Now this again, the Y component of TAB is in the negative Y direction, and this time we're going to use cosine theta. And, whoops, sorry about that, just pressed something with my hand by mistake. So now we've got plus CY minus these two 240 Newton forces that we've got, both of these. So I'm just going to add them up here on the fly. So minus 480 newtons is the sum of those two forces. And that's equal to 0. So again, we can go ahead and solve this. CY is the only unknown. So we should be able to solve for that without too much trouble. And we're going to get a value for CY of 1680 newtons. And we get a positive value for that, which also tells us that that direction is in the positive Y direction, which is straight up. There we go. Okay, so next thing we've got to do is just to kind of resolve that, find that the direction of the overall force at C by doing the Pythagorean theorem using these two components. And then we can also do the inverse tangent to find the angle. So again, pause the video, go ahead and have a go at that right now. And then hopefully what you found was that C has a magnitude of 2.32 kilonewtons, or 2,320 newtons. And we're going to have an angle up from the positive x-axis of 46.4 degrees. Okay, so there we've got that. TAB we found along the direction of this cable, and C we found the two components that we've then combined to find the magnitude and direction of that. Okay, so with all these problems, fairly straightforward. You're going to be doing a pretty similar thing. Generally, sum in moments, sum in forces in each direction. So let me know if you have any problems. Drop me an email or see me in class.